Basic AI with Springboot.
Decision tree is a structured way of making predictions based on various factors. In this decision tree, we have three factors. One is temperature, rain, and sun. If temperature is greater than 15, we go to the right side. If temperature is less than 15, we go to the left side. So let's just see greater than 15, right side. Then we check sun. If sun is there, then we put on t-shirt. Otherwise you go for sweater. If temperature is less than 15, we go to the left side and see rain possibility. If rain possibility is there, then we go for umbrella. Otherwise you go for sweater. It simplifies the decision process. In this tutorial, we explore decision tree, ARFF file, how decision tree help AI program that convert ARFF file to decision tree. 5. Running and test the program. 6. FAQ. 7. Understanding the tree. Let's see the Boston housing data. It is the ARFF file. It has 14 features. Stream, ZN, Indus is industrial. NDX is nitric oxides. RM is average number of rooms per dwelling. So it has 14 attributes. And at line number 16, here is the data. So based on the data, we find the price. So 24 is the price. That is 24.
How decision trees help AI. Decision trees simplify predictions by 1. Keycap identifying key features which attribute matters most, RM first, then NOx, etc. 2. Keycap creating simple decision rules if RM 6.5 and NOx 0.5 price is high. 3. Keycap handling nonlinearity automatically. Unlike linear models, trees split data naturally. Program is a Springboot 3.4 application integrated with Weka, a popular machine learning library. It builds a decision tree classifier, J48 algorithm, using data from the housing dataset in ARFF format. Here's a breakdown. Defines Springboot version 3.4.4 and manages dependencies. Weka dependency, machine learning library. REST controller, API endpoint. Defines Weka train API endpoint. Calls Weka service.train model to train the J48 model. Returns decision tree as a string, making it easy to visualize. Call API in browser Postman REST client. See the trained decision tree printed as a response. Understanding the tree. Each condition checks a specific attribute, like number of rooms or crime rate, to split the data into smaller groups, helping to make predictions. Start at the top, RM happy smiley 6.545. If a house has 6.545 rooms or fewer, go left. If it has more than 6.545 rooms, you take another path, not shown here. Next condition, dis happy smiley 2.0 to 18. This measures distance to employment centers. If the house is closer, go left. If it's farther, go right. Further breakdown with NOx happy smiley 0.668. NOx represents air pollution levels. Lower pollution goes left, higher pollution goes right. As we move deeper down the tree, older houses, it happy smiley 98.9, tend to have lower values, tilde 10.2. Newer houses have slightly higher values, tilde 15. Areas with more industry, indes 18.1, have mixed values based on crime rates, CRIM. What does this mean? This tree is predicting housing values using key attributes. More rooms, RM, higher home value. Farther from city center, DIS, possibly lower value. Less pollution, NOx, higher value. High industry, INDES, value depends on crime levels. Using it practically. A buyer can use this to estimate house prices based on location and features. A seller can check which factors impact price the most. Urban planners can analyze real estate trends in different areas. FAQ. Why is raw data hard to interpret? The dataset contains numerical features like CRIM, crime rate, RM, average rooms per dwelling, and NOx, pollution levels. It's not immediately clear how these attributes influence housing prices, class attribute. Linear models struggle when relationships between features are nonlinear. Tree. How does a decision tree help? A decision tree breaks down complex decisions step by step, making predictions more interpretable. 1. Keycap feature selection. The tree chooses the most important features first. Example, RM, rooms per dwelling, might split first, indicating housing price depends strongly on the number of rooms. To keycap rule-based predictions. Instead of complex equations, the tree follows if-then rules. Example, if RM, 6.5 and NOx, 0.5, then price is high, class 35. 3. Keycap handling nonlinearity. It divides data into meaningful segments instead of assuming a fixed equation. Example, a house near a highway, RAD 5, might have lower value, even if it has many rooms. How it helps AI. Improves explainability. AI models become more interpretable, rather than just black boxes. Reduces processing time. Instead of checking all features, AI prioritizes the most useful ones. Better for small datasets. Works well when there's limited training data. Part 2. Deep learning. In this tutorial we explore below. Deep learning. Training. Normalization and scaling. Generalization. How deep learning help AI. Define a neural network in Java. Program that trains and predicts. Running and testing the program. Understanding. FAQ. Deep learning. Training and predicting with DGL plus Springboot. Deep learning is a type of AI where computers learn from examples, like how humans learn from experience. Instead of writing rules, we give the computer data, and it learns the pattern. Think of it like training your brain to recognize faces, voices, or even diseases. 1. Keycap. What is training in deep learning? Training means teaching the model using data. Just like kids learn math by solving problems repeatedly, a deep learning model learns by adjusting itself to fit the input-output pattern. Example? We give input, like numbers 1 to 13, and output, like target value 10. The model adjusts its internal values, called weights, until it can guess correctly. Real-life analogy? Like a child learning how to ride a bicycle, trial and error until they get it. What is normalization and scaling? Imagine you are comparing apples and mangoes. but one is measured in kilograms and another in grams. You can't compare unless you scale them. Normalization is a method to bring all data values to a common range, usually 0 to 1. Normalized, I, is equal to, rho, I, min, max, min, scaling between 0 and 1. Why it's important? Helps model learn faster. Avoids bias due to bigger numbers. Makes learning more accurate and stable. What is generalization? Generalization is the model's ability to work well on new data or unseen data. Goal of any AI model is equal to don't just memorize, but understand patterns. Example? If your model only recognizes red cars, because it saw red cars only during training, it's memorizing. If it can identify all cars regardless of color, it's generalizing. How deep learning helps AI? Table. Use case benefit of deep learning notable study stat. Healthcare detects cancer in scans better than radiologists. Stanford, AI detects pneumonia with 92% accuracy. Voice assistance understands natural language. Google BERT improves search intent detection by 10x. Finance, India, detects fraud in UPI net banking. ICICI Bank, 70% frauds stopped using AI. E-commerce, Flipkart, personalized product recommendations. 30% boost in click-through with deep learning models. Java plus DGL deep learning program. Add dependencies. Spring Web for REST API. Springboot starter. Deep Java library, DGL, for deep learning. PyTorch engine. Deep Learning 4J Core. MXNET engine. Add dependencies in pom.xml. Modify your pom.xml to include DGL and reinforcement learning libraries. Code endpoint. Add get mapping, train. You send a new 13-element array, and it predicts output like a mini human brain. Code endpoint. At post mapping, predict. Public float predict, at request body float, input data. Training the model. Takes dummy data with 13 features. Trains a neural network using MXNet plus DGL. Saves the trained model for later use. This method loads a trained deep learning model and makes a prediction based on the input. It's like asking a machine, hey, based on what you've learned earlier, what do you think this new data means? Create resources to manage tensors. ND Manager helps manage memory of data tensors, just like RAM Manager. Model.NewInstance initializes a blank model with the name trained model. MXNet. We are using the MXNet engine here. Think of this as turning on the brain and preparing it for prediction mode. Normalize input data. Scales data between 0 and 1. Normalization helps avoid bias due to large values. How to run and test. Run the Springboot app. Access HTTP localhost 8080 AI trains the model. Use postmin to post 13 feature input at HTTP localhost 8080 AI predict. Get predictions. How to run and test. Run the Springboot app. Access HTTP localhost 8080 AI trains the model. Use postmin to post 13 feature input at HTTP localhost 8080 AI predict. Get predictions. Predictions is 30. Model generalize better here as we use 500 epochs, which is good. Concept simple explanation real world link. Training teaching AI with example data students studying from books. Normalization scaling numbers for fair learning converting kg to gm for comparison. Generalization performing well on new data recognizing new faces. FAQ. Q. Can I use this to predict house prices or exam scores? Yes. Just change input data and labels. You can start small, build apps, and solve real problems in education, student scoring prediction, healthcare, early diagnosis, finance, fraud detection, retail, inventory forecasting. Notable findings from Indian study table. Study org field deep learning impact. AIIMS plus IITD healthcare detected diabetic retinopathy with 94% accuracy. Flipkart AI Lab e-commerce 32% increase in customer engagement. SBI AI challenge banking fraud detected anomalous transactions in 1 millisecond. Biju's AI engine education improved student performance by adaptive testing.